def greatest of left and right. If left greater than right, return left, else return right. Greatest of 3 and 22. Okay, I'm done testing. Functions can take more than one parameter. In fact, they can take any number. Well, any number that will fit into memory. Okay? You can have lots of parameters. If you've got more than 3, you better have a damn good reason. If you've got more than half a dozen, rewrite your code. Serious. Okay? One of the most famous bugs in history resulted from the fact that one piece of code was passing the coordinates of a rectangle to another. It passed in x0, y0, x1, y1. Okay? The function was expecting x0, x1, y0, y1. Perfectly reasonable. The first one is saying low point, high point. That's how we're managing rectangle coordinates. The second one was saying, well, give me the x extent and the y extent. Also perfectly reasonable. The more parameters there are, the greater the likelihood that people will accidentally transpose them. And now it's okay if they completely forget one. If you need 3 parameters and I only give you 2 or I give you 8, you can detect that quite easily. Wrong number of parameters. If you need 4 and I give you 4, they just happen to be in the wrong order, hopefully your code will blow up because it was expecting string, string, integer, integer, and I gave it string, integer, string, integer. Okay, hopefully the code will try to do something with the string or the integer it's not allowed to and it'll blow up. But if it expects float, 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 and I give you float, 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 right? Oh dear. Right? Silent failure. The worst thing that can happen. Okay? So, if you've got more than 3 or 4 parameters, the chances that people will accidentally transpose them in the calls climbs very steeply. So don't do it. You see a function with 22 parameters, what you've seen is code that is almost certainly, if not wrong today, will be wrong soon. Okay. At this point, I have to step back before we get on to one other topic for the day. If I say 7 plus or minus 2, green card if you know what I'm talking about. Red card if you don't know what plus or minus means. Okay, cards down. The original work was done in the 50s, but the result had actually been known since the 1920s. And to illustrate it, let me step back a little bit. How many people are on a sports team? Yeah. Somebody said it depends on the sport. It actually doesn't. The answer is about half a dozen. And if there's more, it naturally breaks down into smaller groups. A rugby team is not 15 people on the field. It's 8 forwards and 7 backs. A baseball team is not this many people. It's the outfield and the infield. Because, to first order, human memory can be modeled as having 2 modules. Okay? This is a very crude model. Much better models are available. But first order approximation, your brain and the brain of every other healthy human being has 2 types of memory. Type number 1 is working memory. It's very accurate for short periods of time, where short is measured in seconds, and it can only hold about 7 plus or minus 2 discrete and unrelated pieces of information. Okay? That's your desktop. Long-term human memory is, as far as we know, unbounded. You can remember a whole lot of stuff. We have not hit the bounds. Physically there must be some, but we haven't hit it. Okay? It lasts for a very long time. It is of moderate but questionable accuracy. You can misremember things. Okay? And it's slower to access, much slower. Okay? So that's what you've got. You've got a short-term working memory that is reasonably accurate but very small in a very short duration. And then you've got a longer permanent memory. And things can move from short-term memory into permanent memory only through repetition or drama. Very dramatic things transfer immediately. Undramatic things, as you know, you have to repeat a phone number several times to memorize it. Okay? One of the pieces of evidence for that number 7 plus or minus 2, which is only adduced after the fact, is phone numbers. Every country, more or less independently, settled on phone numbers that were about 7 or 8 digits long. Because more than that, and the chances of you remembering the phone number between the time you looked at the phone book and the time you dialed the last digit, back when there were rotary phones, was small. So, you may have variable length phone numbers, which I think the UK still does. Yeah. Or you may have that fixed 7 digits of North America. You say, but what about area codes? The answer is you don't remember an area code as 3 digits. You remember it as a phrase. You don't remember the word cat as CAT. You remember it as the word cat. And this is why your working memory can hold more than just 7 things. You clump them together. You don't remember words as a collection of letters. You remember them as words. You don't remember an area code as 416. You remember it as 416. You even say it as 416. There are changes in pronunciation which reflect the fact that you're chunking things in short-term memory. What has that got to do with code? Okay. When you're writing a program, as you're writing a piece of code, you have to keep straight in your head, what are my variables? Where am I in the loop? What does it mean to be in the if rather than in the else? What's in that list? You've got to keep a bunch of more or less related or unrelated facts straight in your head long enough to write the next line of code. The constraint on that is the size of your working memory. If you've got more than 7, 8, 9 facts to keep straight for a few seconds when writing or reading the next line of code, your error rate climbs dramatically. It's easy to measure. Right? This is closed tests, and the work was done by Green and Petrie back in the late 70s, early 80s. It's the same effect we see when you're reading anything else. Okay? It's just a reflection of how your brain is organized. So, if I've got 6 or 7 parameters to this function, I have to keep track of what are they all for. There's no room left over in my brain to actually keep track of what is the code doing. Right? Now, if they are red, green, blue, I'm applying some sort of a color filter. That phrase, red, green, blue, of course you always do the colors in that order. Any programmer has seen RGB, red, green, blue. It's just the order in which colors are stored. So that becomes one chunk, and the chances of me remembering it correctly go up. If I'm passing you the bounds on a region, of course it's low to high. Right? I mean, if somebody had code that said, right, you have to pass me the high x coordinate and then the low x coordinate, you can imagine that error rates would go up. And the reason they go up is that you're not remembering 2 values. You're remembering it's a range. So you've taken 2 facts and put it down to 1. Okay? That's the constraint on how much you should put in a particular function. If there's half a dozen things in the function, you're still good. 8 or 9, you're pushing the envelope. 15 or 20? No. Okay? Your chances of getting it right the first time are not great. Your chances of reading it correctly, your chances of somebody else reading it correctly, your chances of debugging it when it goes wrong, not going to happen. Okay? Not going to happen without a lot of hard work. And this is why, if you watch people reading code, function that's half a dozen, 10 lines long, the pen stays in their hand. 100 lines on the page, they start making notes, circling things, drawing back here. What they're doing is trying to take the stuff that's about to fall out of short-term memory and put it down on the page to remind themselves of what they saw just a few seconds ago. Okay? Question? Or just stretching? Okay. So, when we talk about rules for programming, most but not all of the rules I'm trying to teach you can be grounded back in human information processing. There's a reason for this stuff, and it all comes back to how your brain is wired. If you've got 400 lines of code in one function, you're doing it wrong. I mean, sure, if all you're doing is saying x equals x plus 1, x equals x plus 1, x equals x plus 1 100 times, then you can probably keep track of what it's doing, but that's what loops were invented for. Right? So what you're trying to do is write things that are about that long. There's a reason a paragraph on a printed page is a particular size. And yes, there are novels that have paragraphs spanning 19 pages. And there are single sentence paragraphs. But take a look at a novel or a textbook. Paragraphs about that long. That's the size of the lump in which you think. And that's one of the reasons why your functions should look about that size as well. Okay? You probably won't notice the error rate climbing or dropping as you change the size of those things, because you're not keeping stats. You're not recording how many bugs you have in a piece of code second by second as you write it, as you test it, as you fix it. Right? Other people have done that. So you can rely on the results. You're looking for If it's that long, you're probably okay. If it's longer, you're not. If it's got more than half a dozen parameters, you should find a way to factor it out into smaller pieces.